Section 1, Video 3. Let's look at some examples. And we're going to set this one aside because it's different than the others. So if we look at our rational equation, we have to first of all decide what is the common denominator. Now this is 1 over 1, so the common denominator in this case would be x. Now for all terms to have a common denominator, I would multiply this one, top and bottom, by x. Once that's done, we can rewrite this as 5 over x plus x over x equals 1 over x. And once you have a common denominator, you can drop the denominators, and you're left with just the numerators, which give you an equation you can solve. Now I did forget one important piece, and that is that when you find your common denominator out, you should also then ask what can x not equal. In other words, a restricted value, or an excluded value is another way to say it. And x cannot be 0 because it would be undefined, or the fractions would be undefined if you got 0 for an answer. So once you start to solve it, you have to remember that it cannot be that excluded value. Here we have -4. It is not the excluded value, so it works. Again, I'm going to go out of order because these are all similar here now. 1 over 1. In this particular case, the common denominator is p squared, and p cannot equal 0 because 0 squared is 0. So how do we get that common denominator? Well, everything has the common denominator except for the second fraction. So I would have to multiply top and bottom by p squared, which would give us 1 over p squared equals p squared over p squared, plus p minus 1 over p squared. Again, once you have a common denominator for all the pieces, you can drop the denominators, and you're left with just the numerators. And now we have a quadratic equation, in which case we want to get everything on one side, so I'm going to switch this around. I'm going to subtract 1 from both sides to get everything on one side, and I get a -2. Now again, I put the variables on the left side here just because that's more typical. It's a trinomial, so we see if we can factor it. We get p, and we're looking for two numbers that have a product of -2 and a sum of +1. So a +2 and a -1 would do it. Now here's the zero product rule that says, how do I know what my solutions are? I take each one and set them equal to 0. I take each binomial and set them equal to 0 and solve. So p would equal -2 and p would equal 1. Neither of those are the excluded values, so that works. So two solutions in this case. And this ends Section 1, Video 3.